Hello, hello, hello. Hi, I am Jyotin Muhantu, and this is my project, NLP-based. It's a backend system that lets users upload documents and then ask natural language questions to retrieve relevant information from those documents. So, as you can see, this is my ML model project structure. As if, as you can see, I have built a backend which contains API having directories like modules containing backend um, Python files like ORM models.py. I've also used routes where I have placed three Python files ingestion, query, and schema. And also I've included service directory which includes document process, query engine, and schema discovery. These all are Python files. In backend, I've also uploaded a data directory which will mainly contain the PDF or the PPT which will answer the NLP questions. Now coming to the front end part, I've included this public which contains index.html file and under SRC there is a um, directory called components which contain database connector which acts as a JavaScript file which connects the model to database. Then the second one is document uploader, which we will see in the FastAPI where we will upload any document to Epic engine so that it can read the document and answer the queries. This is query panel. You can see it acts as a base gateway to uh, allow to ask questions. And this is result views. It will help you to view the results. And this is app.js, it's a JavaScript file to showcase the app. This is Docker Compose, which is used as for the company phase. This package JSON, rebuild.md, and requirement text, which will contain all the required libraries we need to fulfill this project. So that's for my uh, project structure. As you've given me the assignment, it's exactly the same structure I built. The backend handles all the NLP logic, while the frontend can later be used to build a web interface. Um, this project combines multiple technologies. FastAPI is used to create RESTful APIs. Transformers from Hugging Face are used for text embeddings, specifically for the mini LSS model. FAISS, which stands for Facebook AI Similarity Search, which is recently getting very famous, helps store and retrieve embeddings efficiently. Extract is also used to extract text from PDFs, Word documents, and the file types you will see. And requirement.txt, I've mentioned all these libraries which will help for further process. As you can see, my requirement.txt contains fast API, which will help me content UVCon, SQL, parentic sentence transformers, fast US CPU, as I have mentioned, FASS, Facebook AI similarity search, which helps to store and retrieve embeddings efficiently. This is textract, as I've mentioned, it is used to extract text from PDFs, which will upload this document uploader to JS. And Python multipart AIO files is input output files, UVCon, Zinza2, request, and Python.md. These are the required libraries we need to install for this model. Um, so we can I can show you the codes. You can see the code. Uh, just basic front end code you can see. And the most important code is this backend ORM models to provide. This is the main code. You can see from I've imported all this SQL SQL I've imported in requirement.txt. Per column, it is string data float. These all are basic terms in SQL. We will see how it is getting implemented in this project. This is class, and I've mentioned the class employees, department, init to go. These all are basic queries in DBMS. You'll get to know when I will explain the my API. So now, coming to the main part, let's go to the now backend part. Okay, here we go. This is my window PowerShell, and this is the website. The where NLP query engine is implemented. It's a temporary website. It can only be opened only when the backend is going on. So uh, I've already made it ready so that you can easily view it and get to know how the thing is happening. Uh, so see, when I will refresh it, you will see a new information getting popped up. See, many times I'm refreshing it, and you're seeing it's getting the open API.json file. So the number of times you will refresh this window, you will be getting new refreshments here. Like you will see it open API.html. I think it will be same IP address, but yes. So this shows that it is working. So first I will upload a sample document using the API in this documents endpoint. You can see this API, this document database. As you can see, this connect database we have mentioned here in this part of the backend. This part of the backend database connector.js. This is directly connecting this ingest documents. I have mentioned in here ingestion.py. Okay. So first, I will upload the sample document using this. The document is then we will see how the document is will be processed. Its text will be extracted, chunked intelligently, and embedded into vector representations. These embeddings are stored in FAISS index for fast semantic research. Okay, so let us just upload a document. Um, I will upload just a minute. Upload a document. I will try it out. Here you can see there's a gateway to upload document. Let me upload my CV. This is Jyoti CV2. You can upload any PPT. I'm just referring to any random PDF. I have uploaded it. You can see now. I will execute it. So the moment I click on the execute button, you can see how. See when you can see it's getting a new IP address with uh, having all the requirements like post API ingest documents. It is getting executed with a new HTTP link, and you can see the details of my file. So the it is saying that yes, the IP address is 127.0.0.1.8000. This is the IP address of the website. It is accepting the API ingest documents from the API ingest documents uploaded it. As you can see, content type it's multiple form data. My file name is getting um, I can see my file name here, Jyoti CV2 PDF type. Request URL we can see. Uh, we can also see the content length is 65. Yes, and response body yes count one. We can see here So you've got all those required information while I uploaded this. Okay, fine. Now just let us check the database part. Okay, try it out. Now I'll execute. So you can see again the number of time I'm clicking execute. You can see 400 bad requests. Uh, just a minute. Just wait a minute. Yeah. So you can see um, it's given error because it could not pass SQL URL from the given URL string. It's because it's a random PDF. PPT doesn't have that uh, proper schema or proper structure for for us to get a SQL query. That's why you need to upload a right document for this thing. Now, if we okay, here we can see that the document has been successfully processed and indexed. Now, I will show you how to query, ask a query in the API. You can see this is for the API. Click on try it out. Here you can ask any query. Just say you can try out any query like what does this document say about Python data analysis? What does the document shows about the person? What are his education qualifications? You can ask as many questions related to those PDF. Okay, and you can find click on this execute to get all these things. It's showing argument error because I haven't asked any question. I've just shown you a random PPT of my resume. You can upload your own PPT and ask your own queries to get it. Now the system encodes this query into the same embedding space and finds the most semantically similar chunks of text. The results show the top matches along with the relevant scores and source document paths. Uh, so let me explain it in easy way how it works. Internally, what happens that when documents are uploaded, text extracts the text. The text is split into meaningful chunks using dynamic chunking logic. We can say each chunk is converted into an embedded vector using sentence transformer. All vectors are indexed by FISS, which allows fast similarity search. Um, we can say if when a query or a question comes in, it's also converted into an embedding, and FISS retrieves the top matching chunks. I can show you. Let me show you my structure processor.py. Just a minute, guys. Uh, this is my query engine. You can see how I have used SQL clean, SQL strip. All these are the basic elements of SQL thing, which we have did in DBMS. That was management system. Uh, this all allows for further classifications and processes to follow in SQL schema. This makes the system much more powerful than simple keyword search. It can understand semantic meaning of a question. Okay, uh, you can see this. Yes, that's it. You can see it can. I've you imported SQL and Kimi from the requirement text, and I've used an function diff analyze database self connection string and str. It connects to database and returns a dictionary. You can see I've used tables, relationships, samples. That's it. Relationships for table calls and tables or items for calls for first basic for loops for tables. Uh, So, what does this make? This makes the system much more powerful than simple keyword search machine. Okay. So that's the NLP query engine, a complete end-to-end backend that supports semantic document search and query processing. It can be extended further to include database querying, Superbase integration, or a React front end. This backend can serve as the foundation for intelligent document assistance, resume search tools, or enterprise knowledge retrieval system. Uh, so I will show you the final. Yes, this is the website, fast API interface. Yes, that's it. It's not completed, but yes, it's almost done. As you can see, it's perfectly getting executed with a valid IP address, but it's temporary IP address. It can only run when the backend is running. Once I will terminate this PowerShell and will my terminal, it will also get terminated. So it's very temporary. I'm just that's why I'm recording this Loom video. So thank you. That's it. Thank you for watching this demo. That's what I built. Hope you like it. Thank you.